Number 5. The forces of attraction between molecules in a molecular compound are generally B. Weaker than the attractive forces among formula units in ionic bonding. Now, this is a fairly simple idea. It goes back to pluses and minuses, electrostatic attraction. If I have a positively charged species and a negatively charged species, and they have a full 1 negative charge and a full 1 positive charge, there's going to be a certain amount of electrostatic attraction. If I somehow shield or mitigate some of that positive charge, the resulting electrostatic attraction will be less. Makes sense, right? If I shield some of that positive charge from the negative charge, there will not be quite as much attraction experienced. However, if I increase the charge from 1 plus to 2 plus, there's now more charge and therefore more electrostatic attraction being experienced. So it's a very simple concept. When there's more charge involved, there's more attraction. Or, not in this case, but there could be more repulsion. When we're talking about the forces of attraction between molecules in a molecular compound, we're talking about covalently bonded atoms. Covalently bonded atoms that are sharing electrons. Not only that, they are the electrons that are furthest away from the nucleus, the nuclei of those atoms. And so there's a pretty significant difference from, a significant distance from the source of the positive charge in those atoms. And so with all these things in mind, there's less of a force of attraction in a covalent bond when you compare it to the attractive forces in an ionic bond, which is a full positive charge and a full negative charge. And sometimes it's even more than that. Sometimes it's a full 3 positive charges and a full 3 negative charges. You're going to have very, very strong attraction. There's not going to be any shielding by all these other electrons, the inner shell electrons, the kernel electrons that surround the nucleus of an atom, like you experience in covalent bonding. When you have a molecular compound, there's going to be a significant amount of shielding, and the effective nuclear charge will be less. In the case of ionic bonding, you have a whole charge and a whole negative charge and a whole positive charge at least. Oftentimes, you have even more than that. So the forces of attraction in a covalently bonded compound, a molecular compound, are generally weaker than the attractive forces among formula units in ionic bonding because of the difference in the magnitude in charges.